Bismillahirrahmanirrahim. Now we will try to explain this dissolved oxygen SAG curve, and we will explain this analysis with the help of Streeter-Phelps model. Because, as earlier explained, we are concerned with determining a balance between the um, rate of uh, um, reaeration of oxygen into the system and the rate of deoxygenation within the system. We need to determine the balance, and we also need, by using this balance, we will also determine at what distance we will be having and what distance and what time. Both are our variables, time and distance. We are having the critical deficiency in the oxygen demand. So for this case we need to define the terms like critical DO deficient, and then we will also define the critical time. So by equating this equation we will be solving it. Before going to that detail, we will be just having a revision, like all these things we talked about earlier. Like these are the self purification processes which will be playing their role in reducing the organic content and pollution load in our water bodies. So like starting with the dilution and then currents and temperature and then sunlight, rate of oxidation, oxygen sag. Here you will see that this oxygen deficient is equal to the saturation DO minus actual DO. And then these are the zone of pollution in the stream. We talked about these earlier. We have a clean zone, then we have a decomposition zone, degradation zone, this decomposition zone or septic zone, and then zone of recovery, and then clear water zone. So after these explanations, we have a clear idea what's happening with the waste, biodegradable waste, which is disposed in the drains, and then how this waste is being decomposed. So oxygen deficit D is equal to saturation DO minus actual DO. This is the basics. And then the GO in the stream may not be at saturation level because there will be some of the organic content already present in the drain. So that's why DO would not be at its maximum saturation level. So this is we have talked about this, and now you will see here, this is the same oxygen sag curve, and we will be having some initial deficit. This initial deficit is due to the already existing pollution, and then it will be further reducing to a critical point where the deficiency will be maximum, and then again the oxygen will start saturating, and it will reach the maximum level of saturation. So here is this Streeter-Phelps equation. Basically this equation is derived from balancing two things. And what are those two things? Those two things are the rate of regeneration of oxygen and rate of rate of depletion of oxygen. So both of them will be balanced, and then we will be comparing it between themselves, and then we will derive the equation for um, this oxygen deficiency DO, and then at the same time we will find the critical time as well. So if you just I want you to have a basic idea about this. And at the same time, when we talk about the pollution load which is entering into the system, and which will be based on the regeneration of air, that will be directly linked with the amount of organic content which will be expressed in terms of BOD. So again I will request you to recall the idea of biochemical oxygen demand, and again how BOD is expressed. So BOD is expressed normally in terms of the rate of decomposition of the organic content. So that is like DL over dt. With the passage of time, how much where L is the organic content, ultimate organic content. So that organic content is being decomposed, and then it will be with passage of time, and then we will determine, and this rate is actually decreasing because it is BOD is the amount of oxygen required to decompose the organic content. So this requirement is gradually decreasing with the more decomposition of organic content. So these are some of the solutions, and so just go through these procedures. Actually it needs a complete derivation. The Streeter-Phelps equation is also known as DO-SAG equation, and so here is this equation for different conditions. So K1 is the deoxygenation rate, and K2 is the re-aeration rate, and here LT is the oxygen demand remaining after time t. So this LT is coming from our BOD equation. This LT is the same, and then we will be having DO critical, which will be the difference between the saturation and minus D critical. So furthermore, if we know the time and we can multiply it with the velocity with which the water is moving, and then we can find the distance as well, at what location we will be getting this deficient oxygen. So this was something about the basics. So please go through these slides for your information, and this is actually the Streeter-Phelps model used for the dissolved oxygen SAG curve analysis.